All right, guys, so today we're talking about concavity. So we'll talk about what that is first, and concavity has something to do with slopes or rate of change is another way of saying it. So we'll talk about what concavity has to do with slope, how they affect each other. And then after that, I'll give you a function and I'll ask you, can you describe the function's concavity? And we'll be doing that by looking at equations and also by looking at graphs. So that's the goal for today. Yeah. All right. First thing I want to make sure that you guys are good at is understanding slope. So down here at the bottom, I've got various numbers. Those numbers represent, I'm hearing some side conversations. Can we stop those? I've got some numbers down there at the bottom. They represent slopes. And I want you to match each slope on the bottom with the line that it goes with on the top. Now, it's not on your notes, but I just want, or is it? Is it on your notes? Yeah. It is? Yeah. Okay, then just go ahead and draw a line matching each number to the slope. I'll give you a second. So I'm going to start asking you guys what you got there. Kimberly, which one did you say that was? I agree. First of all, it's negative because it's going in that direction. Second of all, it's steep. The more steep a line is, the bigger the slope. So, David, I'm going to ask you a more specific question. Which one is the negative half?
That is the fourth arrow.
You're right. So this is also negative because it's going in a downward direction, but it's a little flatter. So it's still negative, but it's less negative, right? It's only a negative half. The same thing applies when it comes to the positives. So let me ask Matthew, what do you think this one would be? It's a steep one going in the upward direction. Yeah, that would be 2. Whereas this one here would be the half. 0 is a flat line. So there you guys have it. So you should have, I want you guys to have a sense of slopes here before we begin. We're talking about concavity, and I told you that concavity has something to do with slopes, so we want to make sure that we have an understanding of slopes. So what is concavity? Well, first of all, let's tell you what it is. Concavity is the boldness of a function or a line. What do I mean by that? This is what we would call concave up. Looks like a bowl, right? And if the bowl is facing upwards, well, then that's concave up. If it's upside down, then we would call that concave down. So that's what concavity is. It's the boldness, which way the curving is going, basically. So the next question we're going to look at is, so what does that have to do with slope? So I'll show you. Can I delete? All right. So how concavity relates to rate of change. Now I'm going to use the word rate of change for now, but I'll write above it slope just because that's our brains understand that a little bit better. But rate of change just means slope. But I will be using the words rate of change. So when I say that, just know I'm talking about slope. All right. Now I'm going to start off with this rate of change. Positive or negative? Okay, I'm going to call that a positive. I'll call it 2. Now I'll make another slope. Positive or negative?
Positive.
More or less? Less, because it's a little bit flatter, right? What's this slope?
That is 0.
0. What do you think about that one? That's going to be a negative. And this one's going to be more negative because it's steeper, right? So I'll call that negative 2. Now when I put all those slopes together, what would you say is happening to the slope? It goes from 2 to half, to 0 to negative half to negative 2. That's true. It is the function's concave down, but what's happening with the slopes? They are. How are they changing? They're decreasing. So there's your answer. So David pointed out, hey, what do you know? That's concave down. So when your slopes are decreasing, that makes a concave down graph. So concave down that means that slopes are decreasing. Or not, I don't want to say slopes though, right? I want to say rate of change. So rate of change decreases. So if you ever have a function where the slopes or the rates of change are decreasing, then that's going to create a curvature that looks like a concave down graph. I forgot to write the word down, so make sure you do that. Concave down means that the rate of change is decreasing. And so the flip of that is true, right? If your rate of change is increasing, what do you think that's going to do? That'll be concave up. I'll still show you a picture. So let's say I start off with a really negative slope, and then a slightly less negative slope. It's a little bit flatter. And then 0. And then a little bit positive. And then a lot positive. Now my slopes are increasing. And notice the curve that makes. That makes a positive, a concave up. So concave up means that the rate of change, the slopes, is increasing. So we know what concavity means now. It's just the bowl shape of a function, whether it's facing up or down. We know how it's related to slope. If the slope is increasing, that makes concave up. If the slope is decreasing, that makes it concave down. So we have our two main ideas there established. And can I clear?
Yes.
Any objections? Looks good. Okay, this chart is kind of a summary of everything. Now I've got half bowls here, right? Both of these halves are concave up. You guys see how those are concave up? They're just halves of the bowl. Now, since both of those are concave up, that means they have an increasing rate of change, right? The slopes are increasing. But there is something different about those graphs. This one's going in an upward direction, whereas this one's going in a downward direction. Okay? So, even though they both have an increasing rate of change, the functions are doing different things. In this case, we would say the function is increasing because it's going up. This one, we would say the function is decreasing because it's going down. So there's two words there that I want you to separate in your brain. Function and rate of change. Okay? Here, the function is increasing and the rate of change is increasing. Here, the function is decreasing, but the rate of change is still increasing. How can you tell the rate of change is increasing? No, that's how you can tell if the function's increasing. So let's say that then. How can you tell if the function's increasing? It goes up. How can you tell if the rate of change is increasing? What do you think, Alexis?
If it's like this is how I would say it would think the half of the bowl.
There you go.
Already filled is like pointing upwards.
There we go. So if your bowl's upwards. So you could tell if the function's increasing if it's going up. You could tell if it's the rate of change is increasing if the bowl is up. It's concave up. Does that make sense? So over here, both of these are concave down, right? So both of those have a decreasing what? Rate of change. They both have a decreasing rate of change because they're concave down. But the functions are doing different things. Is this function going up or down? So we would say this is an increasing function with a decreasing rate of change. It's going up, but curving down. This one is a decreasing function because it's going downwards, and it's also curving downwards. So they're both decreasing. So I want you guys to get those two divisions in your brain straight. There's function, rate of change. You could tell if the function's increasing by whether it's going up or down. You could tell if the rate of change is increasing or decreasing by concavity, up or down. Okay, those are different ideas, different words. I want to parcel those out. So let me give you guys a question here to see how well you're getting this. Don't look at your notes. Don't look at your notes.
Okay.
So I'm going to ask Evan, concave up or down?
Down.
Concave down. Good. Now, Ruby, increasing function or decreasing function? Decreasing, I agree, because it's going down. And let me ask Annalise, are the rates of change increasing or decreasing? So the function is decreasing. Is the rate of change increasing or decreasing? Not sure? Okay, why? Does anybody know why she's right? Because it's concave down. There you go. So let's do another one here. Don't look at your notes. No, I don't want to do that one. Let me do this one. All right. Let me ask Haswani. Concave up or down? This one is concave up. Yep, we've got an upwards facing bowl. So that's concave up. Now, next question. Going to, no, Michaela's not here. We got a lot of people out today. Andrew, is the function increasing or decreasing? Why is the function decreasing?
The bowl is concave up.
So I liked your answer, but your explanation I didn't. The function is decreasing because why, David?
Because it's going down.
The line's going in a downward direction. The function. All right. Brianna, is the rate of change increasing or decreasing? Huh? Why is the rate of change increasing? Because it's concave up. Okay, so let's do one more. One more. And then but don't look at your notes. Here we go. Setis, is this function increasing or decreasing, and how do you know? It's increasing. How do you know? Because the graph is going up. So my function is increasing. All right, next question. Hannah, the rates of change. Why are the rates of change decreasing? Because it's concave down. Good job. All right. So I think you guys have got it there. At least I've tortured it as much as I'm going to torture it for now. All right. So now that we've got that, let's move on to a question now. Example 1. Give an interval where the function is concave up. So, do you guys agree that from here to here it's concave up?
Yes, sir.
Okay.
Yes.
So how would you describe that interval? We're going to go ahead and use brackets, I guess. That's fine. It starts at -6 and it ends at 0. There. This does not erase very well. Okay, let's do another one. Give an interval where the rate of change is decreasing. Okay, now we got to think about that. What happens with your graph when the rate of change is decreasing? Okay, let me go to Alexis this time.
0.6.
What?
So my question is, what happens to your graph when the rate of change is decreasing?
It starts to instead of the slope going positive and increasing, it starts to
So the slope is getting
less steep.
less, or it could be getting steeper depending on whether it's positive or negative. But I'm going to say the question again, then I'm going to let David take a crack at it. But your sentence was true. But I'm looking for an easier answer than that. So when your rate of change is decreasing, what does your graph look like, David?
Concave down.
That's the word I was looking for.
Oh.
So this is just
You're gonna ask me.
well,
Too late.
I tried, but he spit it out. The rate of change is decreasing. That's just a fancy way of saying concave down. So where is it concave down, you guys? You see where it's concave down?
Yes.
Where?
0.6.
That's concave down, right? So we're going to go ahead and write that concave down. 0 to 6. Okay, next one. Give an interval where the function is neither concave up or down. So what do you think, David?
6 and infinity.
There you go. This on that side over there. There's no concavity there. It's just flat. So we will say from 6 on to infinity. And this is a detail that I don't know how important it is. I'm not too worried about, but parenthesis, not bracket. Parenthesis means it can't equal that. You can't equal infinity, so we put a parenthesis. All right. Give an interval where the function, now this is a different question. I'm asking, give an interval where the function is increasing. Not where the rates of change are increasing, but where the function is increasing. So let me well, okay, go ahead.
0 and 3.
I agree. Now let me show you guys. So he said 0 and 3. The function's increasing. That means my graph is going up. Do you guys agree it's going up there? So that's fine. You could have also gone a little further. You could have did that whole thing. You could have said from -3 to +3, because that whole time it's going up, right? Now the concavity is different on this half and this half, but it's still going up the whole way. So it doesn't matter. There's more than one answer here. So I'm going to go ahead and put 0 to 3, because that's what David said. But there's more than one answer. Do you guys see? I don't see any other increasing ones, though. I don't see anyone. All right. Now, where is it decreasing? So that means going in a downward direction. I'm not looking at the boldness anymore. I'm just looking at the direction. So where is it decreasing? Well, I see it's decreasing here. I see it's decreasing here. So either one of those are good places to say the function is decreasing. So it doesn't matter which one you put. I'll go ahead and put -6 to -3. All right. Now number 6. Give an interval where two things are going on. Concave up and decreasing. So first of all, let's find concave up. That was here, right? Now where at, that's concave up. Where at on that orange area is the function decreasing? On the left half or the right half? The left half. Over here, the function is going down. So it's concave up and decreasing. So we would say, what interval? There we go. All right. Why don't you guys try this next one here real quick? See if you guys can find it. I'll give you a second. Give an interval where the function is concave down and decreasing. All right, Charity, what do you think? 3 to 6 is right. Good job. So, on this interval here, it's concave down and it's moving in a downward direction. All right? So, I think you guys can find concave down and up pretty good. I think you can kind of see where it's increasing or decreasing. Just watch out for these ones. If I say the rate of change is decreasing, that's just a fancy way of saying concave down. If I say the rate of change is increasing, that's just a fancy way of saying concave up. Okay? So you got to watch out for them fancy words, but there it is. All right, here's one for you guys. You got 3 to do. I'll call on you in a second to share out your thoughts. All right, so there's our answers to student practice 1. Let's go ahead and move it along. All right, so here's another way I'll ask the question. I'll give you an equation instead. We have to graph. Now, actually, you're going to be thankful.
Thank you.
So what we're going to do is we're going to graph it. Now, before I go any further, I want to explain something to you guys. I've got a function here, but do you guys see this? That's an interval. I'm giving you an interval for a reason. Because some functions, they're not always concave up or concave down. They could be a lot of things. Like, you could have functions that look like this. So it's got different concavity in different places. So I'm asking you, what's the concavity of this function on this interval? Only from x equals -2 to x equals +2. Okay? So how do we do that? Well, we're going to make a chart, an x and y chart. You're going to start with the first number that they give you. You're going to end with the last number they give you. And I would say let's pick at least, I don't know, 3 numbers in the middle if possible. So what comes after -2?
-1.5?
Yeah, but let's be nice. So you really could pick any number, but we want to pick nice numbers. So, you know, I guess 4 might be enough, but 5 is probably better. The more points you have, the more you're going to see the shape of the graph. Just so you know. All right, so we just have to find the y values now. Once we find those y values, we can plot the dots, and we can just look. Oh, is it concave up or concave down? Okay, so it's not too bad. No. And then you're going to show that to the other class, and they're going to be mad at you. All right. So I'm going to plug in negative. Yes. Oh, thank you. I'm going to plug in the -2 first. So -2 to the 4th power is 16. -2 squared is 4. So I get -16. Why don't you guys try the next one? Yep, you just keep plugging them in. Why don't you guys try -1? Plug in -1. I'll ask you what you got in a sec. Neve, did you get one? What'd you get? -7? I agree. Now I'll do the rest just for the sake of time. It looks like this. Okay? And now we're going to go ahead and graph it.
What?
You don't agree?
Yeah.
May you illustrate further upon -7 and 1?
Well, yeah, if you plug in 1, you're going to get 1 minus 8 times 1, which is -7. Now we're ready to graph it. Let's graph it and see. My y-axis goes down to 16, so 2, 4, 6, 8, 10, 12, 14, 16. My x-axis only goes out to 2. So let's graph that. -2, -16. -1, -7. 0, 0. 1, -7. 2, 16. So if I connect these, what would you guys say that is? Concave up or down? Concave down. That's it. So question for you guys. Are the rates of change increasing or decreasing here? Decreasing because it's concave down. So that means the slopes are getting smaller or decreasing. Right? All right. So there's one for you. Yes.